All right, we'll get back to section 3.3, and let's take a look at this problem here. I got a couple of examples where we're going to find all the zeros. Now, a zero is the same thing as an x-intercept. Okay, keep that in mind. So, because if I want to find the zeros, I need to find all the x values that are going to return 0. Well, if I want to find x-intercepts, what do? I set f of x to be 0. That's the same problem, right? So if we want to find the zeros of this guy, we need to find all the x values that are going to return 0. Okay, so set the function equal to 0 and then solve for x. If we divide by 3 and then set each of these factors equal to 0, here's x minus 1 squared equals 0, means that x minus 1 is 0, so x is 1. And 2x plus 5 equals 0 means that x is negative 5 halves. Okay? Now, 1 is a 0 that has a multiplicity 3. Okay, so in other words, there's not just 2 answers here. There's 3 answers. The 3 answers are 1, 1 again, and negative 5 halves. Okay, so there's 3 zeros. Now, usually when we have a 0 of multiplicity, 2 or more, we indicate that, just somewhere on the side. Otherwise, if the 0 did not repeat, we don't indicate it had a multiplicity. You can if you want. You're gonna say that there's multiplicities then for every x value, which kind of sounds like like there'd be a lot of writing there. So anything that has a multiplicity of 2 or more, go ahead and indicate that. Okay. Here's another example. So what if we had the function g of x equals x cubed minus 2x squared minus 9x plus 18. Okay, we're going to do lots of things with degree 3 and degree 4 polynomials coming up here. Okay, now I'll show you some things for how to find the zeros. Regardless of what I show you there, don't forget about the things that you've already learned. Okay, so factoring, I don't have a common factor in all 4 of these terms here, but I can factor by grouping. Okay, so let's go ahead and use that approach. So we're going to let the first 2 terms be one group and the last 2 terms be another group. Out of group 1, what's in common there would be x squared. Okay, so let me go ahead and bring out an x squared out of group 1. That would leave me with x minus 2. Now, to have the factor by grouping method work, I'll need another x minus 2 coming from group 2. If I can't get that, then this method's no good. Okay, and then I gotta figure out another way to solve for x. If I factor out a negative 9, okay, that's going to leave me with x minus 2, right? Negative 9 times negative 2 is 18. So x minus 2 is in common to these 2 groups. Okay, let's go ahead and factor that out of the whole thing there. And so the leftover from group 1 is x squared. The leftover from group 2 is a minus 9. So I got x minus 2 times x squared minus 9 equals 0. Okay, when I set each of those equal to 0, x is 2, or x squared equals 9 means that x is plus or minus 3. Don't forget about the plus or minus there. Okay, so I've got 3 zeros. They are 2, 3, and negative 3. Okay, by the way, something that I want you to notice here, the degree of the polynomial is 3. And I had how many answers? 3. Okay. We just got done doing a lot of things with quadratics in 3.2, and the degree of a quadratic is 2. And how many answers do you always have when you solve a quadratic equation? You just have 2 answers. Okay, there's a connection going on there. Okay, and I'll talk about that later on. But let's take a look at this problem next. So what if I had the function h of x equal x to the fourth minus 8x squared plus 15? Okay, and I want to find the zeros for h. So let's set the function to be 0. I need to find all the x values that are going to return 0. And this is a degree 4 polynomial. Okay. Again, you guys are going to do lots of things with degree 3 and degree 4 polynomials coming up. Okay. But again, don't forget about the things that you should already know here. Okay, so this is a degree 4 polynomial. What also can I call this? Like, this looks very much like a quadratic equation, right? We know a quadratic equation is an equation of the form ax squared plus bx plus c equals 0. Well, instead of the powers of x being 2 and 1, they're 4 and 2. But I still have 3 terms. I'm adding them together, and I got 0 on the right. Right, so this looks like a quadratic equation. Okay, we call this quadratic in form, and let's use a u substitution to solve this equation that's quadratic in form. By the way, you always use a u substitution to solve an equation that's quadratic in form. Okay, I'm going to let u be x squared, and to figure out what u is, u will always be the middle term. Just disregard any constant that's there. Okay, so I'm forgetting about the minus 8. U is x squared. So if u is x squared and I square both sides, u squared is equal to x to the fourth. Okay, well, I got an x to the fourth leading off. I'll go ahead and replace that with u squared. Minus 8x squared, that's what I'm calling u, plus 15, that's equal to 0. And by making that substitution there, I can see more clearly now that I had a quadratic going on. It was a quadratic all along. It was just kind of hidden in disguise a little bit. Okay, so knowing that I've got a quadratic equation, let's go ahead and factor this. This one will factor. So u minus 5 times u minus 3. U times u is u squared. Negative 3u minus 5u is negative 8u in the middle. And then negative 5 times negative 3 is 15 at the end. That was good. Okay, so then u equals 5 or u equals 3. Now, here's the thing. I don't care what u is. U is just a temporary variable that helped me solve for x, right? The original equation is involving x. Okay, so let's go ahead and substitute back. U is x squared. So I'm going to say x squared equals 5 and x squared equals 3. If x squared is 5 and I take the square root of both sides, x would be plus or minus, don't forget about that, plus or minus root 5. And then x squared equals 3 means that x is plus or minus root 3. Okay, so in all, I have 4 zeros. They are root 5, negative root 5, root 3, and negative root 3. Those are the 4 answers. Okay, by the way, I had a degree 4 polynomial. There's a connection going on there. Okay, and again, we'll talk about that later. All right. The last thing in this section is some information with the difference quotient. The difference quotient is a really important formula that you do a lot within calculus. Okay. The difference quotient of f is a function, is f of x plus h minus f of x all over h, where h is some number. H can't be 0, though, because I know I can't divide by 0. Okay? It says that the difference quotient is used in calculus to calculate rates of change. Okay, so what if I had the function f of x equals 4x plus 7? Let's compute the difference quotient of f. So, well, I'm going to say f of x plus h minus f of x all over h. So just use the formula. Okay. f of x plus h means that wherever I see an x in f, there's only one x showing, I need to replace that with x plus h. So I got 4 times x plus h plus 7 minus f of x. Okay, so minus 4x plus 7. Now you're subtracting the whole thing, 4x plus 7. So you'll need parentheses around that 4x plus 7 there. That's necessary to have. Okay, and this is all over h. So let me go ahead and distribute the 4 and then the negative into these terms. So I got 4x plus 4h plus 7 minus 4x minus 7 all over h. And here's where I'll have some things canceling. Okay, 4x minus 4x, those are gone. Here's 7 minus 7, those are gone. And that's going to leave me with 4h divided by h. h over h is, those are gone. So the answer is 4. Okay. Now I have a linear function. We did things with linear functions in chapter 2. Okay. The difference quotient for a linear function is always going to be equal to the slope. Okay, so the slope of this line is 4. The difference quotient would also be 4. If I gave you, a totally different function, suppose that f of x is negative 6x plus 5, and I wanted you to find the difference quotient of f, that's going to be negative 6, right? Because the slope is negative 6. Okay, so that works fine for a line, but what if I have some curve that's looping around and doing a bunch of weird stuff? Okay, well, the difference quotient is a way to describe to someone how to get from one point to the next on a curve. So if the curve happens to be a line, how do you get from one point to the next on a line? You can use the slope. Okay? So yeah, what if I had a curve that's not a line? Well, let's compute the difference quotient for that. Now I want to know how to get from one point to the next on this curve here. F of x equals 3x squared minus 5x plus 1. So the difference quotient, I got f of x plus h minus f of x all over h. F of x plus h means that where I see an x in f, there's 2 x's there. They have to be replaced with x plus h. Okay, so I got 3 times x plus h squared minus 5 times x plus h plus 1. And then I'm subtracting f of x, subtract the whole thing, so I need parentheses around that. Because the next thing I'm going to do is distribute this negative here into these 3 terms. And this is all over h. Okay, so then from that, let's see, x plus h times x plus h, that would be x squared plus 2xh plus h squared. I got the 3 in front of that. So leading off, I'm going to have 3x squared plus 2xh times 3, that's plus 6xh, plus h squared times 3, that'd be plus 3h squared. And then it's going to be minus 5x minus 5h plus 1, and then let's distribute them negative here into these 3 terms. You got minus 3x squared plus 5x minus 1 all over h. Okay, and I'll have some things canceling here. So here's 3x squared minus 3x squared, those are gone. Negative 5x plus 5x, those are gone. Okay, and 1 minus 1, those are gone. And that's going to leave me with terms only involving h up top. By the way, whenever I have a polynomial and I find the difference quotient, I'll always have some things canceling up top. That will always happen. Okay? And the terms that will remain are going to be all the terms that involve h. Anything not involving h is going to go away. So let's see, h is in common to all 3 of these terms, right? Let's go ahead and factor an h out. That's going to be with 6x plus 3h minus 5. And the h that was factored out can be canceled with the 1 down under. So I'm looking at 6x plus 5h plus 3h minus 5. Okay, and that'd be the answer there. Okay, now the difference quotient is a way to describe to someone how to get from one point to the next on a curve. So like if I were at x equals 1 and I wanted to know how to get to x equals 3, h would be 2 units away from 1. Okay, so x is 1 and h is 2. Well, that's going to mean that I'm going to have, let's see, 6 plus 6 is 12, minus 5 is 7. Okay, so if I draw a line going from x equal 1 to x equals 3, then the slope of that line would be 7. Okay, and that would be one way to describe to someone how to get from one point to the next on that curve. Okay, you go up 7 to the right one, up 7 to the right one. Okay, now you do more with the difference quotient in calculus. As I said, there's a lot more to know about that. All we're going to want to know how to do is just to compute a difference quotient. Okay, so make sure that you know how to compute this using the formula. That's gonna be all for that we'll do here in this class. Okay, so here's the homework in section 3.3. Be sure to look at those problems, and we'll go ahead and stop the video right there.